Migrating birds across the harvest moon, information, examples, and filming protocols. You know, about this time of year, the harvest moon, September, October sometimes, birds suddenly appear around the full moon. Not a Halloween story. You doubt me. I hear people laughing. Well, here is a picture of the moon I took. Concentrate. You see the birds around the moon? You're not paying attention. The great naturalist John Burroughs in 1908 on the art of seeing things wrote, "If we think birds, we shall see birds wherever we go. If we think arrowheads, as Thoreau did, we shall pick up arrowheads in every field." So let's concentrate. It's September 20th, 2021 in Dana Point, California, 9:18 p.m. Just a second. I think I see something on the upper left. Yes, there's a bird going across the moon. You see that? Well, you might have blinked. So let me show you that again. Except this time I'm going to zoom in on that part of the moon, 300% zoom, and slow down what you just saw for 1/16th of a speed. So you ready? Here we go. Sure looks like a bird to me flying over the surface of the moon. You can see the wing beats. Let's try that again. A little bit later, 9:38 p.m. So you thinking birds? Are you thinking birds? Just a second. Look up. Look there. There's another one flying by. And I'll do the same protocol here, showing you it. Slow down. The bird is closer to us. It's fuzzy, not as high in the air as before. Now I must admit I'm cheating a little bit because those two pictures, those two videos, aren't representative of most of the birds that you will see moving across the moon's disk. Most of them are very, very small. And this video is going to tell you about the technique for moon watching, for photographing those birds, and what was happening on those two videos. There's an article in 2013 by a person by the name of Bob King, if I read it correctly. In fact, let me increase the magnification on that. And his title is "Tonight's Harvest Moon is for the Birds." Really? Well, actually, I wouldn't have used those terms. For the birds comes from house sparrows in New York City in 1890s that were feeding on undigested seeds in horse manure. So when you say something's for the birds, that's not necessarily a good thing. But this is a good thing, this harvest moon and birds. And Bob continues and says tonight's the harvest moon, September 18th, 2013, the full moon closest to the fall equinox, the moon where farmers could continue to bring in their crops because of the light cast by this full moon, and it rose very, very soon after sunset. It's a perfect time to catch a big orange moon on the horizon, and the annual fall bird migration. Every September and October, anyone, including you can do it with a small telescope or spotting scope magnifying 30 power magnification can enjoy the sight. He also published an essay in 2018, and I'm showing you the address for them on the bottom of this slide. So you could always stop it and get these addresses. Bob says that watching birds pass across the moon in a small telescope is a very pleasant activity. What else you got to do? Reminiscent of meteor shower watching. At first you see nothing. Then blip, a bird, meteor flies by. You wait another minute, and then suddenly two more appear in tandem. That must be a good migration night there. Both activities give you that delicious sense of anticipation of what the next moment might hold. As field naturalists, people want to experience nature. And this quote from a very famous philosopher, that you can learn a lot just by watching. If you can watch the moon, you can learn quite a bit about birds. This person is maybe known to you. His name is Yogi Berra. So let's do a little bit about bird migration to give you some background. I'm going to use a curriculum book for 6th to 8th grade students at the Point Reyes National Seashores, teaching them about bird behavior and birds that were there. And there's a section on migration. I will edit it a little bit. And the curriculum says that migratory birds are nature's superheroes. Every year across the world, not millions, but billions of birds must travel great distances to get to important destinations, their winter home and their nesting home. Traveling over land and sea, using paths called flyways, we use that again, that expression, the miraculous event is called migration. In North America, hundreds of thousands of migratory birds, and we know that's really billions, fly north to their nesting home in the spring and back south to reach their warmer winter homes in the fall. Some birds must travel over 8,000 miles. Can you imagine that? Just one way. And some never make it to their destination. And this curriculum talks about the Pacific Flyway. The Pacific Flyway is a stretch of sky and land that spans across the Pacific region of the United States, Canada, Central and South America. It is an airborne highway. You don't see any signs along the way, but the birds know they're there. It's a highway to millions of bird commuters that must migrate annually to and from their northern nesting grounds in Alaska and Canada, and in the northern part of the U.S. as well, besides Alaska. These birds follow unmarked pathways, using guidance systems that surpass human instruments. Birds use sites along their flyways to feed, rest, or nest and rear their young at the end. These birds migrate hundreds or even thousands of miles southward to their wintering grounds in the fall. Kind of neat. Where I am in Dana Point, California, is on the Pacific Flyway. We don't get as intense of a migration as the central part or the eastern flyways, but there is activity up there. So the evidence for bird migration, if you're a birder, you know that the bird species change over the period of the year. And right now in Southern California, I'm starting to see FOS emails, first of the season, as white-crowned sparrows are coming in to their wintering grounds here. So we see appearances of the same bird species on their southern winter grounds when they disappear from their breeding grounds. We also have information from banding birds and the returns that we get. But if you really want to see migration in action, see birds actually moving, you can go to some places and do that. In California, for instance, you can go to Goleta Point near Santa Barbara and see in April, for instance, thousands of Pacific loons migrating north. You can go down to Anza Borrega Park and see the Swainson's hawk migrating through Anza Borrega. They roost there at night and then they take off in the morning. You can go to Golden Gate Raptor Observatory and see people counting hawks and vultures that are moving overhead. And there are radio telemetry projects that will follow birds in flight. But the two I'm interested in telling you about are the bird silhouettes across the face of the moon, and I'll tell you how I videotaped that, and radar movement of birds, which have superseded this moon watching to a great extent. So a lot of people are now using radar to predict and to follow the relative densities of birds that are moving in any given day and location. There is a very nice article by the Cornell Laboratory of Ornithology about radar and birds and how you use radar to track bird populations on the move. They also have there's an article on Birdcast, a website that predicts migrations in your area based upon mainly radar. And the information is there. So I enter Dana Point. I find Dana Point there, and it tells me that the days that I'm going to be filming around the harvest moon was going to have low migration. That's too bad. One of these days, maybe I'll hit it when there's moderate or high. I found this interesting on the Birdcast website, that Birdcast provides live and local bird migration alerts throughout the continental U.S. by employing real-time analysis of bird migration traffic as detected by radar. You can use this tool to determine whether birds are migrating in your area tonight in low, medium, or high densities. Maybe you can sleep or later. You don't have to go out all night. These alerts serve, though, an important conservation need. They can provide timely information about nights of high intensity migration. Those are called peak migration. Only a handful of which occur throughout a given season. So instead of just relying on chance, you can go to this website and reduce your effort. This allows effective targeting of the most important migration nights in a season when lots and lots of birds are migrating at night, helping determine when to act for maximal effect of conservation actions, such as turning off lights on buildings that often are sources of mortality of songbirds when they're migrating, when birds are flying at night to avoid luring them towards artificial light and potentially fatal hazards. So I hope I've gotten your interest up. What can you expect if you go moon watching for birds? Well, it turns out that Bob has given some information on that here. He says, and I quote, "As you might suspect, most of those birds that you will see around the harvest moon cross the moon from north to south. They're going to the south, with the other third traveling either east to west or northeast to southwest. Only one little silhouette flapped back up north in the wrong direction." And he continues that according to a bird observatory located in Indianapolis, most nighttime migrators begin their flight right after sunset and continue until about 2 a.m. Peak time is between 11 p.m. and 1 a.m. Never gone out that late. Birds typically migrate at altitudes ranging from 1,500 to 5,000 feet. So they're a mile above you between you and the moon. But on some nights, altitudes may range from 6 to 9,000 feet. And now this is important if you go out. I could tell the high ones from the low ones by their size and sharpness. Nearby birds flew by out of focus, and they go by quickly, while distant ones were sharply defined and took longer to cross the moon. And as you might expect, they're going to be a lot smaller. So let me show you that. Now I'm going to show you two video segments illustrating what I just told you in the last slide. This is a indication of when a bird is very close to you, and you're just going to see a blurring shape going very quickly by because it's not very far away. So here is the video. Look on the bottom of the moon and see how fast that flew over. And now let's go to a higher magnification and slow it down 1/16th speed. And it's a blurry object because we're focusing on the moon some distance away and not something that might be 100 feet above us, 200 feet. Not quite clear how high that object was. Here is a second video indicating a bird that is very, very high. This might be the highest that I recorded during the times in the field during this harvest moon. And to help you, I've put where the bird is going to appear on the moon's disk. That's where that start is, and where it's going to leave the moon disk, and that's where the end is. And to make it even clearer for you, and I'm going to be doing this for many of the other video segments later, I'm going to highlight the corridor. I'm going to highlight the corridor. And, I spoiled you with the first two video clips of large birds flying over the moon. So let's see this. This is not going to be a very big object going through. Look at the start, and let's see, on the count of three. 1, 2, 3. There it goes. And you can just see, in fact, it's not going into a straight line. It looks a little bit wavy. Now it's almost to the top, and now it's at the end. So for those of you who didn't get a chance to really see that well, and I am doubtful that people with smartphones with small monitors and screens would be able to see that, we'll repeat it again at 300%, zooming in and slowing it down to a 16th. And we're going to go from the bottom left. You can just make out how high this bird is. I have no idea whether it's a small bird or a large bird, but the fact that it's going so slowly over the surface, while some of the others that I've already showed you going very quickly, indicates that it's some height above me. It looks like with the changing of density that we're actually seeing the flapping of the wings. And I stopped it there, but you can imagine how that was 30 seconds, how long it would have taken just to go through this standard section that I'm going to show you for all the videos. Now, when I looked at some of the references, no one seemed to be concerned about the possibility when you go moon watching for birds that you'll see bats, or maybe owls, or nocturnal birds like nighthawks. Maybe flying insects could be in your line of sight. And my question is how high do these animals fly? If they're close to the surface of land where the food items are, they're probably going to be out of focus and go through very quickly. It's only in the blurry zone close to your position that they might be found. So I think that the working assumption seems to be that any high-flying, active, quote, moon animal during the fall and spring migration periods is a migrating bird. But there's lots of things up there. There are, possible UFOs. You never know. For instance, here we have September 19th, 2021, 9:28. You're going to look at something that's going to go down from top to bottom of the screen. You figure out what we're looking at. I'm going to put the highlight. I'm going to turn this on, and I don't see it. There it is. It started coming down. It's a very small dot. It's about a quarter now, going down. Looks like it's going in a pretty straight line. Doesn't look like they're flashing of the wings halfway down. Now getting to the darker area there. That doesn't look like a bird. And now it's out. And now let's take a short look at it. And you know what you're looking at? The only thing that I think it reasonably could be is a satellite. Now, normally satellites are seen because the sun is reflecting off of them. In early night, you'll see a satellite, but it's really unusual to see a satellite as a silhouette. And so this was just one of those lucky chances that I got to actually get this on camera. So you never know what you're going to see in terms of a man-made structure. Wouldn't it be neat to have the International Space Station here? And I stopped the video, but you would it would be a long time before we actually see the full route of this slow down to 1/16th speed. I also found this interesting article about bats and the fact that this study indicated that on a full moon, bat activity is actually reduced. This is mainly for bats that feed close to the ground or on water bodies, not necessarily for those higher up. So another reason why perhaps that the things that we're looking at, those moonbirds, are actually birds and not bats. So how do you observe this? What sort of equipment do you need? It's certainly not like a meteor shower. And it turns out that in 2004, the University of Arizona was encouraging the citizen scientists to go out and tally birds crossing the moon. And they had a set of instructions, and these are often quoted and cited for helping people observe moonbirds. And they indicate that with good visibility and a telescope of 20 to 30 power magnification, nocturnally migrating birds can be recorded at altitudes up to 1,500 meters. And that's above you, right? Elevations. So, well, that's good. I don't know how many of you actually have telescopes or spotting scopes. Many of you have binoculars. What about binoculars? Well, if that's the only optics you have, go for it. You might be able to see the birds as big as the ones I initially showed you. It might be a challenge with the last one. But seeing moonbirds takes patience and ability to detect motion of small objects. Holding binoculars steady and looking skyward gonna create strain on your neck for long time intervals will prove difficult. Also, 90% or more of these birds will be small, barely noticeable dots racing over the moon's disk. You're going to get discouraged pretty fast. But try it. So for instance, I'm going to show you here, this is a video. This is probably going to be very fast and very small. Going to start at the top and toward the bottom of the video. Now, the way the video is set up, by the way, this is not the way the moon actually looks because of the angle of the camera, and I'll explain that later. So let's put our highlight here. Look at the start on the count of 3. 1, 2, 3. There it goes. Wham! Now, that wasn't a satellite. If you were able to follow that through, you saw that it was not in kind of a straight line. There was also an indication of wing flapping. Let's look at it with our standard magnification and slowing. And now you can see not only is this bird wing flapping, but it's also gliding. And then it will flap at the bottom. So different birds have different styles, and I'm wondering if you can get closer to an identification. It's pretty difficult to identify these birds to species. The instructions at the University of Arizona 2004 says that normally one cannot distinguish different species of birds by moon watching. However, many nocturnal migrants give flight calls while they are flying. And I've seen people post online I heard a migration of yellow warbler last night by their flight calls. They also recommend for the study, this 2004 study, we highly recommend that each person watch only for 10 minutes at a time to prevent visual fatigue. You can be staring at the moon looking for this small motion. Regular pauses of at least 5 minutes for people watching alone, who are also recording information, must be made in order to maintain the necessary concentration over an observation period of a few hours. Now, one of the things they tried to do in 2004 is to figure out the size of the birds that they were looking at. And what they did was they indicated they would compare it to the size of the crater, the Tycho crater. I don't know if I'm pronouncing that correctly. And so the instructions said that there were going to be 7 size classes of these birds, of these silhouettes. Very, very small. And in fact, you probably have seen some of those, all the way to very large, mostly fast shadows. And I tried to do this. In fact, I had an advantage because I could slow down my video and then put a circle the size of Tycho and then look at the birds. But there's a big difference between this bird with its wings extended and not. But you can see that 36 of the birds that I tallied were a quarter or less the size of that particular crater. To give you an idea, um, you can see that the Tycho crater, it's right to the left, toward the left of end on there. I'm going to show you a bird that's going to start and end there, and it's going to fly right underneath the crater to give you an idea of how small it is. Remember, 90% of birds, and in my case it was even higher than that, are smaller than that crater. Okay, so on the count of 3. 1, 2, 3. And there it goes in the center, right underneath it. Just touched it. And that would probably be a 1. Now, if we actually looked at it under slow motion, we can actually see the wings moving. So I think in 2004, those observers would not have seen that, and they would have said, just a point of silhouette moving across, didn't really, you couldn't distinguish it as a bird at all. But again, this may be a very high-flying bird. It could be big, it could be small. Is not clear, but from our view of it, it has a small shape. Now, one of the things that the 2004 group did was they asked people to draw a line on a template of the moon showing the direction of birds. And I thought that would be a neat idea. And I'm going to show you such lines, but I have to adjust what you're seeing on the video. So let me explain this. This is kind of a technical little section. But first I'm going to show you three more videos. I think that might be the last 3. Give you an idea. I had a lot of videos. Initially I had 14, then I cut it down to 10, but I have videos of all 42 of those events. Okay, on the count of 3. 1, 2, 3. Now this is a little bit larger bird. You can see the wing action. You can see the wing action. And it's going to go across this a lot faster. So you can see quite a bit if you slow things down. With the naked eye, it's not going to be as easy. Also, you notice that as it's moving, it seems to be getting smaller. And I think basically when it came to the left side of the moon, it was as close to me as it was going to get at that point. And then as it moves down to the right, it's actually moving away from me, and therefore it's getting smaller. Here's another one. Start, end on the count of 3. 1, 2, 3. And that wing action at the very end, I saw a number of birds within a couple of hours or a couple of 3-minute sequences of that. I'm thinking maybe they were all the same species. A view of that, at least the first part, it would be much more interesting to see the last part where it was really flying with a lot of wing beats. And again, it's moving actually away from me. It's not just moving, upper left to bottom right. It's moving away. And then I think this is the last one. You notice they're all going left to right. In fact, by adjusting this to where south would be, going south, I would rotate this by 90 degrees clockwise. And therefore, most of these that you're seeing are going south, which makes sense during the fall migration. On the count of 3. 1, 2, 3. Now, I was doing a little bit of recentering of the moon in the camera. That's why you got that jiggling. Show you it at 1/16th speed. So those are some of the things that you can look for when you go out moon watching. So in order to adjust it and to show you these pathways, for 38 out of 41 bird trips over the moon, I was able to record their entry and exit points. I plotted their movements with a straight line with an end arrow, showing the direction of flight on the circle of the moon as shown on my video frames. I limited the number of such lines per circle graph to 6 or 7 to make the individual paths stand out. I'm going to show you about 6 of them. But those circles of bird transects have to be adjusted as to where north and where south is on the circle graphic. Consider these adjustments as approximations. My open garage from which I filmed the moon phases, and I'm going to show you toward the end of this video exactly how these were videoed and the equipment used. So my open garage from which I filmed the moon faces to the southeast. So I'm facing to the southeast. If the moon was directly in front of my garage, a bird observed going from top to bottom on the moon disk would be going southeast, not south, even though that's the south pole of the moon, they're going southeast. I would have to adjust the circle of transects by 180 minus 143 or 37 degrees clockwise to have south at the bottom of the graphic. The moon was always to my left during my filming, but I did not adjust for that variable. But there's another problem with the circles of bird transects. My camera on an equatorial mount, I'll explain how I did this, is not parallel to the ground, but it's at an angle. So if I were to take a picture of a tree and looked at the actual frame, the tree wouldn't be vertical on the frame, it would be tilted. So based on my measurements done on September 25th, trying to duplicate where the moon was during the previous night's filming, the angle varied from 38 to 45 degrees, and I'll use a middle value of 42 degrees to adjust the circle. And then another problem I faced was adjusting the circle for true north and south, not magnetic. And there is a website that tells you what's called the declination to do that adjustment. And there it is, the National Centers for Environmental Information. You enter information on there, it gives you the declination. And so adjusting for all those factors, and I don't have to read through this, but I come to the conclusion that in order to show you the graphic, I would have to rotate it by 90 degrees clockwise to get true north at the top and true south at the bottom. And I'm going to show you these figures. Now, this is different than the dial of a compass. North direction is to the top. South direction is to the bottom. But if the birds are going to the east, east is to the left of the figure. And west is to the right, as I'm looking at this figure. So I've tilted it 90 degrees. It looks like they're not making up their mind. However, if you look closely, I think there are seven birds here. That 4 of them are kind of going southerly, and some of them are going to the northeast. But this was the most variable of the first, and they happen to be the first 6. Another one where they're going southeast, most of them. Only one of them is going up north. Another one where they're all actually bearing to the south. The one at the top is going, probably to the southeast. Here they're all going to the south. Here they're going to the southwest. And the green one is actually going to the west. So for the most part, yes, these birds are migrating. They're going to the south. Here's the last one. Again, going to the south. I expect that if I did this in April, when the spring migration was occurring, that you see the opposite. You'd see most of these pathways going up. So I expected at my location that birds would migrate to the southeast rather than to the south over the Pacific Ocean. So again, I'm in Dana Point. You can see that the shore line is actually going, southeast. So let's tell you about how I did this. My goals initially were to try to get a good picture of migrating birds against the moon disk, and to test the limits of my equipment for documenting nocturnal bird migration and how to improve the setup, and to provide you, my viewers, with a consistent view of what to expect in moon bird watching. And I hope I've already done that in terms of the videos I presented and the technique to highlight the corridor and to slow down the action. Initially, my first efforts a couple years ago was to try and take a still picture of birds over the moon. Now, you see pictures like that. They're mostly waterfowl, large birds, and the moon behind them is probably a daytime full moon. It's a lot different trying to take a picture of a bird 5 miles above my head flashing over the moon. And by the time I even recognized that there was a bird going across the moon, it was gone. So that's not really feasible, at least not for me. And then what I tried to do was to put the camera on a tripod and take videos and hope that one of the sections of the video would have some sort of a bird movement. And last year I was successful doing that. I was really excited, and I posted a YouTube video on bird migration against the moon and talked about some of the early theories about how birds migrated to the moon. That one person thought that was true. But the problems are that when you're dealing with this on a simple tripod, that the moon moves. It's moving out of the field of view. And when you try and get it back to the center it again, you kind of kick the tripod, you lose the moon position, you're vibrating the camera. It's not great. So the thing to do would be to put the camera or put your telescope or spotting scope on a astronomy mount, on an equatorial mount. And the last year I got a tabletop model and also an electronic drive to run it. They run totally, for both of them, were $200. And on the left side is the battery pack and the controllers. The bottom right is where the tabletop part was there. That can be unscrewed from the equatorial mount. Um, the mount itself, once that's gone, is kind of like a peg that can be screwed onto a tripod. I didn't like that. And so those round circles are actually big washers that occupy that space and provide a better platform for the equatorial mount. On the very right is a heavy weight. And this is what the apparatus looked like with the Nikon P1000 on it, not extended, and the controls. And I was successful last August. Um, there was a blue moon. A blue moon. It's not actually blue. It's every 2 or 3 years there are 13 full moons, and the one that where there are two in a month is the quote blue moon. And I like the title, More Than Once in a Blue Moon, that I put on YouTube, Birds, Bats, and UFOs. But since I put that online, I've not been happy with it. I did not do a good job explaining how to do moon watching, bird migration, etc. And so when I went out for the harvest moon, I removed this entirely, deleted it from YouTube. Even though there may be on Google some information about this, this does not exist anymore. And I did not use any of these bird pathways for this present video. So the harvest moon filming that I did was that the videos were taken with a Nikon P1000 on a moon setting, has a moon setting, and I've recolored them to grayscale. You can I could have photographed the moon when a yellow moon, a slightly blue moon. The Nikon has various hues I could have done. And because the camera is mounted on an equatorial mount, the camera is oriented at an angle to vertical. So those videos you saw, the top of the video that you're looking at is not the actual top of the moon. Okay, so just remember that. The equatorial mount has to be pointed to true north, and that was pretty easy. For my purposes, I found where the compass north was and the correction for true north, and then guess where that direction would be for my tripod, which is at the front of my garage to the back. I must have come pretty close to true north, as the moon position in the camera's field of view didn't require too many recentering during the filming of the moon. For the most part, it was rock solid. It did not move, and if it moved, it just kind of flatten the top, and then I would bring it down a little bit. I zoomed into the moon so it occupied most of the camera's viewfinder. And a still picture taken with the same settings as the video filming showed the camera at an equivalent 35 millimeter lens focal length of about 1600 millimeters or 32 power magnification. That correlates with the suggested telescope or scope power suggested by the instructions article. Now I filmed the moon at 1080 and 60 FPS frames per second for 3 minutes at a time, so I could handle that easily on my computer. Waited about 10 seconds and then repeated the filming 10 seconds, etc. And most nights I did 15 to 20 of these sequences. Although I viewed the filming on the small LCD of the camera screen, I rarely detected birds because they were so small. But on the computer monitors, I could see them. A 3-minute video sequence generated about 0.6 gigabytes of file. I looked at the videos with their original quality on my large monitor. I noted the segments that had flyovers and recorded where in the segment the event happened. Segments with no detected flyovers were deleted to save disk space. To some extent, I'm sorry I did that, because I suspect that birds that just kind of grazed the moon, were at the edge of the moon, went through so fast that I didn't detect them. So there might be a high experimental error. could have checked that. I used OpenShot Video Editor to trim videos with bird activity and also saved the same trimmed sequence at 1/16th of the original speed. So that's where that came in. And I will tell you that the trimmed sequences do not have the same resolution as the originals. So I did some experimenting. On September 16th, I put the camera focus below where the moon's features were clear. In other words, I brought the focus closer to me so that I couldn't see any more the craters on the moon. It was kind of just a yellow blob, thinking that bird flyovers would be in better focus because they would be closer to me in the focus. But it only made things worse, and that night's video were discarded. So I did film on the nights of September 17th through the 21st for not too long, maybe an hour. The moon setting was used. The moon was just in focus, and manual focusing was implemented. September 20th was the night of the harvest moon. So my summary is that I spent 267 minutes of filming during the 17th to 21st. 42 objects were detected, or about one event every 6.4 minutes. And obviously one of those objects was a satellite. So what's next to do? Well, I need to stay up past my bedtime to see the peak nighttime bird activity that people say is where the activity peaks at that time, 11 p.m. to 1 a.m. I need to go out when birdcast migration index for my area is moderate or high, and there's a good moon phase and clear skies. Coastal Dana Point often has clouds in the evening. And my goal is to film a flock of birds over the face of the moon. It would really be nice to see. So I hope you enjoyed this little virtual field trips to go out in your backyard with, hopefully a telescope or spotting scope, but even binoculars. Try binoculars and show you what you might expect, just like a meteor shower. Maybe if a group of astronomers with astronomy telescopes would have a moon watching migration day during bird migration. That would be kind of neat to have something like that. So this has been another of my JDW talks. I have YouTube talks on genealogy topics, a lot of them on the 1950 census that will become public in April of 2022. A bunch of natural history topics, and this I consider one of them, birding optics, etc., and a bunch of other talks of my interests. I used to collect novelty zithers at one time and biology songs. So you have the opportunity to go out on a full, it doesn't even have to be a full moon. The reason people choose a full moon is you get a higher probability of intersecting with a migrating bird. And go out and enjoy yourself, interact with nature, and see what you can find. Bye-bye.